There we go. All right, we'll try one more time. So good morning, everybody. Today is Monday, October 2nd. And before we get started with the material today, I want to go over our schedule with you. So this is our Moodle page. And you'll see for this week, October 2, 4, and 6, we are going to be working on a new coding project. We're going to be talking about graphing and representing data visually using MATLAB. So we'll do that in lecture today. I'll talk about some general stuff. I'll show you a couple of programs, a couple of examples of what MATLAB can do. And then in lecture or in lab this afternoon at 2, I'll have an assignment for you to get started on. So that'll be what we'll do today. Then on Wednesday, 2 days from now, we'll continue working on that, answer any questions as you continue your code. Friday, October 6th, of course, ES 1060 students don't have a lecture that day, but Computer Science 1010 do, and we'll go ahead and continue working on that code. Then on Monday of next week, lecture and lab will finish off the coding project that I'll have for you by this afternoon at 2. And then that'll be it. Then it will be that homework assignment, that coding assignment will actually be due on Thursday, October 12th. But on Wednesday, October 11th is our midterm exam. So that was something that I wanted to talk to you a little bit about today. For your midterm exam, let's pull this up and see if I can make this. The label text is going to be our midterm exam will be held in class at 9 a.m. Good morning, Burkham. So at 9 a.m. on Wednesday, October 11th, period. October 10th, October 11th, I am right. On that day, the exam will consist of a timed assignment. I'll give you a prompt for a short MATLAB coding exercise. And you will have 1 hour to complete it. You will have all MATLAB resources available to you. In other words, the glossary, the help, the Moodle page. But you will work independently. So then at the end at 10 a.m. or before if you finish, submit, I say, or before, submit your code through Moodle. So that's Wednesday next. Then Friday, the 13th, and Monday, the 16th, no class or lab due to fall break. Then when we return on Wednesday, October 18th, we will begin using Excel as our programming platform. Okay, so the upshot of this is, I'm going to post this, it's going to go into the wrong week, I think, but I'll put it in the correct week. The upshot of all this is that after this next assignment, we're going to be done with Excel. So if you have a subscription that's expiring or anything like that, you're off the hook in terms of everything as of Wednesday of next week. All right. So at this point, do you guys have any questions? Good morning, Ed.
Morning.
Oh, you're good. Don't worry about it. Good morning. I see Stephen is here. No questions? Joey, you're in two places. So that's great. And so is Hiroki. Very good. All right, Burkett probably as well. All right. So if there's no questions, I will proceed on and talk a little bit about graphing in MATLAB. All right. MATLAB is fantastic for creating graphs. There's a lot of programs that you may use that you'll find that visually representing data is a terrible multi-step issue, and MATLAB is not one of them. So I wanted to show you a couple of little snippets of code. This first piece of code here called 3-line graphs is one that I wrote that just gives us 3 lines on a particular figure. And I'll show you what it looks like in just a minute. I also wanted to let you know that a few of you had written great code that had illegal MATLAB names and I couldn't open it. I was guilty of that when I wrote this code first because I named it numeral 3-line graphs and MATLAB told me it wasn't going to do anything with it at all. So I had to, so you're not alone in naming it something like that. All right, so basically what this does is it sets up a little array of numbers and it says there's going to be 5 numbers and it's just 1 and 1. So in other words, it's just going, we're going to have 1 row and 1 column with 5 entries in it. The first one I'm calling red and it has these numbers. The second one I'm calling blue and the third one I'm calling green. Then I tell it that I want to plot a figure, which is just that command figure. Hang on, I don't think I'm sharing my screen yet. I should do that. Hang on. No, wrong one. Hang on. Try again. There we go. Okay, so like I said, we set up an array, 1 column or 1 row, 5 columns, or the other 5 rows, 1 column. And I have 3 different arrays. One is called red, one is called blue, and one is called green. Here are the numbers. So in other words, there's no user input. I've just given them, assigned them numbers. Then I tell it to do a figure. Then this is what's very cool. In order to plot this, all I have to do is say plot X red. So in other words, I'm plotting X on the X-axis, red on the Y-axis, which are these values. And then I want it to be the color red. So you just put a dash R like that, single quote R, single quote, and it'll plot it as red. Then on the X-axis, I have blue, which I plot as blue. And the third set of numbers, which is green, plotted on the X called green. And then I give it some limits and some labels. And the Y label, so in other words, on my Y-axis, which is the vertical axis, it's going to see red, blue, and green. And the title is going to say red, blue, and green, where each one of them is capitalized versus X. All right, so then if I run this program, you'll see I get that graph. That's how easy it is. Now, this is, like I said, this is really pretty spectacular stuff that we can do it that quickly. So you'll see that red, blue, green versus X, that's my title that I requested here. The Y label is red, blue, and green. And the X title is just X. If I wanted to change anything about it, oh, for example, the fact that this line is called red doesn't have anything to do with the color that MATLAB is going to produce. It's this little R here that tells me it's going to be red and B and G. So if I wanted to change that, for example, if I wanted to change the X label to be X is 1 through 5, because that's what it is right up here. Then I'm going to save it and run it again. And you'll see it changes that's how easy it is to change the X label of that graph. If I wanted to change the color, I don't remember what are other color options for me here. Let's say yellow. If I want to plot that first line, which is called red, as being yellow. Let's see if it's good. Let's see if yellow is an authorized color. Well, there it is. So see, that's a pretty cool thing. So you can plot any sort of data. This is as much into dipping into this idea of arrays that we're going to use. And it's just because that's the way that, that is just the way that MATLAB perceives the world, is in terms of arrays or matrices. Now there's another sort of a, this is just slightly more complicated, but the graphing part is not. This is a little bit of code that I wrote to take a look at if a student had a certain number of courses in their freshman year, for example. And if they had introductory courses, science courses, humanities courses, math classes, and then specialties. So whatever's in your major, you wanted to do a pie chart of that. The command pi3 actually means a 3-dimensional pie chart, which I'll substitute in just a minute, but you'll see that the command is pi x. So once I set up this little array, I ask it for the input of the percent of introductory science courses, science courses, humanities courses, math courses. And then of course, the total percent of your courses has to be 100%. So it calculates your specialty courses as being everything that doesn't fit into one of those general education categories. And if these go over 100, it gives me an error message that just says we went over 100. Anyway, so then if it doesn't give the error message, it calculates the percent of specialty, and then it tells you what that is. Then it sets up that little array again with 5 elements. X, the array, is equal to intro, sci, hum, math, and spec. So in other words, that's all of your courses. And then here I'm going to create a pie chart with those percentages. So pie charts are just really great ways of showing this sort of thing. All right, so you look down here and it says input the percent of introductory coursework. Let's say it's 20, and the percent of science coursework, let's say 30, and then humanities coursework, maybe 10, and math coursework, 20. Then it calculates my specialty coursework to be 100, and it produces a pie chart. So then you'll see also that I've got the color set as being blue, light blue, green, orange, and some kind of a dark red. So let's see. I want to get rid of that for a second. So, okay, then this is, we could explode it, but so this is another one that you can do, is if you want to, you can explode that. But here's another one that I think is really interesting. The command pi3, if I change that, will just create a 3-dimensional pie chart. So it's the same stuff, but it just looks a little bit different. So I'm going to give some different percentages here. See, and so it just gives you a different shape, a 3-dimensional pie chart. Okay, so that's what our next little piece of work is going to be, is to producing these kinds of graphs, to produce line graphs, and then to produce some pie charts, right? And we can work with these specs. There's another, I don't like to necessarily oversell a command, but there is one command that is just really fantastic in MATLAB, which is called hold on. And basically what a hold on command will do, it's not going to give me a good description here, is just kind of repeat the same thing that you just did. So keep that in mind, and it can save you a bunch of different steps. Let me see if I can come over here, and let's come over here to, oh, I'm in Foxfire, sorry about that. So what is hold on in MATLAB? See if it'll give me a good answer. Hold on retains plots in the current axis, so a new plot is added. So in other words, that's a very handy command if you think you want to add something to something. You can just use the hold on command, and then it'll just take the same data that you already put in. You don't have to reproduce it, and you can just add something to it. So I learned that kind of late in the game. I've been working with MATLAB for several years, and I found hold on, and it was like, it's the best command ever. So it can really get you where you need to go really, really fast. All right. So this is what we're going to do for lab this afternoon. By 2 o'clock, I will have posted to our Moodle page a little exercise for you to get started with line graphs and pie graphs. And I'll probably require some user input, but we may start today with just the piece where you can put in an array yourself and then do some graphs just to play with it. And then on Wednesday, we'll talk about doing the user input, which is a skill that you should be able to bring in from the last program that you wrote. All right. So does anyone have any questions about our work today? You guys are so easy to get along with. All right, so I'm going to go ahead and quit recording, and I will look forward to seeing you this afternoon at 2. If you can't wait, you want to get started, I will have that assignment posted before 2, but I'm not really sure exactly what time, but it'll be up before then. And then we'll meet in SM 135. And then the final piece of the puzzle is, most of you have already been doing this, but I'll pass around a sheet of paper for people who are here, for international students, just to sign in so that I can give that to Kara or Amanda to make sure that everybody knows that everybody's here. All right, guys. Well, thank you for your attention. I'm going to go ahead and stop recording, and I will see you this afternoon at 2.